Okay. So you go to nderive. You put the function in with the vars. You put a comma. You put x because that's the variable that you're using. You're finding the derivative with respect to x, comma, and then you put 2 because that's the value that we want to find the derivative at.
What do you do if you have the...
You push enter and you get 51.001. If you have the other one, and I don't have a way to project this, I apologize.
X, and then you hit...
You're going to, so here, you do the x.
That's kind of cool.
Oh yeah, not there, down here. Okay. You do an x down there. Okay, and then in here we're going to put our function. And again, you could type it, but we already have it saved. Y1, and then you go over here. This is, I want to find the derivative of y1 such that x equals to 2. Okay.
No.
Okay?
What question is this?
This is a random one that's not in the book. You're welcome. We made it up yesterday. Okay, does everyone?
How do you change the variable? Oh, the little foldable?
How do I change the variable?
No, the
You don't want
function.
it to be TV board.
Good question. I think.
Alex and I just sat here confused yesterday.
Carter didn't stop.
I have no idea, but I will find out.
Carter would.
Because sometimes you can just push it a couple.
I knew what I was talking about.
I like derivatives. These are easy. I
will find out. I mean, do we ever?
35 minutes.
In my many years in math, have I ever changed the variable?
You can kind of just.
I can do derivatives.
Right. Even if I have a t or something on my screen, unless I'm talking like theta would only be if I'm doing something polar, and I really haven't had a need to change the variable. Okay, so let's do the one in the book. Number 4. If f of x equals x cubed plus 3 to the x, find f prime of 2. So remember, we can use our calculator for finding a derivative at a specific value. We can't use our calculator just to find like the general derivative, you know, like the equation.
Not
the function.
cool.
Okay?
Calculator.
I know, right? I mean, there are other places on the internet that you can find them, but that doesn't help you because you actually have to know how to do it.
I'm gonna get those Amazon glasses. Like read my brain. Just
All right.
It on the lens.
So we're gonna put it in. We're gonna put this function in. I'm gonna put it in y2 just because I don't know. I don't like erasing functions because I never know when I'm gonna need them again.
Are we gonna need that one again?
I don't know. Probably not.
I erased it.
You can erase it. Okay.
Where are you getting this number from?
Number 4 in your book. If f of x equals x cubed minus 3 to the x.
3. Oh, I hate the ones to the x.
We're trying to find the derivative at 2
Number 4.
on page 47.
Oh.
So the first way we can do it is we can push graph.
2.112.
Oh, hang on, I gotta take this one off. See,
How do you take it off?
I just went over to that equal sign and I push enter on the equal sign to see how it either highlights or unhighlights the equal sign.
So much easier.
So you go to graph, and then I calculate the derivative by going to the calc menu, which is second.
Isn't it plus 3 x to the 2?
Sure is.
Frick. Carter. Quiet.
There you go. Better?
Yeah, I was like, I didn't get the same graph.
No, you are correct. Thank you. Okay, so second, calc, derivative, and we want to find the derivative at 2.
Well, it looks way different now.
What? Yeah, I got that.
Okay, if you did not get that, I will come and take a look and see what you need. Did you get it?
Yeah.
Okay.
Nate, your problem.
I don't know how I'm getting it. I did something wrong.
Is it
Okay.
21.8875?
You
I
get
got it right here,
17.
but on the graph.
What?
That's on the video now.
I'm confused. I got 17.
So then you enter 2.
You did it
I was
It's
Okay.
When I put the function in
That's also why
the other
you're
one,
failing
I've
math.
got the function
Dude, I
right.
probably would be too.
You get 17 also? Bryn, you get 17?
No,
just
it's
look
y
at the
equals
line.
17. Look at the top part. The dy
Ah.
slash x is the actual number.
Okay, it's just showing up in a different part of your.
It's just telling you what y is too, even though you don't really.
There we go.
That's
Yeah, we were just looking in the wrong spot. So where it says dy dx, that's your derivative at that point. Okay, so you can try it the other way.
What does that even
To do it the other way,
Why do we have to do it the other way? This way.
n derive.
Whoa.
Do we have to do it the other way too?
It's good to have a few different tools in your back pocket because you just never know which one is going to work
practice
better.
maths?
Math, 8, and then you do n derive, and then you.
How do I get B's?
Bars.
How do you get b?
I accidentally hit the wrong key.
So you hit alpha instead of second. So you go over to the bars.
Zoomed all the way down.
You select your function, comma, your variable, comma, and the value that you want to find it at.
I did it fast.
Oh, I selected the wrong function. See, I should have just deleted it in there, shouldn't I? Make sure you know where your function is if you have it at y2. Is it frustrating you, Carter?
No, Levi messed it up and I laughed at
You
you.
hit it out of my hands.
Always someone else's fault. So we get the same if we do it this way as if we do it in the graph. Everyone feel good about finding derivatives on your calculator?
Oh yeah.
I figured the thing out I asked you about.
Okay.
You have to change, so you go to mode, and function it's always x, parametric it's always t, polar it's always theta.
Makes sense. Right, see, because I was saying you would use theta in a polar, but that makes sense. Okay, so now we have the rest of the time to ask questions and to work. Do you guys want to ask any questions as a whole, or do you just want to look and start practicing? Are there any ones that you looked at last night that made you nuts?
Number 4. Wait. What? I don't know why I
16.
circled it.
16? Okay.
I'm hungry.
Given that g of x, okay, g of x equals x times f of x. Use the product rule to find g prime of x. We want to find g prime of x. Now this is confusing because when we named, in our product rule, we named something g of x, and then they give us a function that's g of x, so that's really frustrating. So let's rename this h of x and h prime of x so that we can use our mnemonics that we already know. Because it doesn't really matter what that function is called, right? Okay, so this is h of x, this is h prime of x. So now let's figure out, this is f of x, obviously. And this would be g of x, right? This is two different functions multiplied together. Do you agree with me there? So then we're going to make a little chart. We have f of x, and then g of x is just x. Well, what's f prime of x? F prime of x, because we don't know what f of x is, so we just write f prime of x. And then what is g prime? 1. So now we do fig plus gif. So it would be f prime of x times x plus 1 times f of x, which is just f of x. Does that make sense? It's too theoretical for you, isn't it? It would be so much easier if those were numbers, wouldn't it?
Yeah.
Yeah. If this was like, if f of x was like x, or 4 to the x or something, at least if it was a function. Okay. I think we need to do another just plain old product rule, like an easy product rule. Okay, I can see that. Let's do.
How do you derive something when it has this power of x? You just do like,
Power of x?
Yeah.
I think we will learn those derivative rules later, but
Okay, well, I thought I needed it or something.
you probably shouldn't.
Maybe it was the number 4 we just did.
Can we?
I don't think you're gonna need it, but if you do need it, I will show it to you.
Okay.
shouldn't need it yet because we don't know how to derive that yet. We only know how to derive things that have like constant powers. Can we do what?
For 60B, like finish it. You just
Oh,
plug those
yeah.
in.
Okay, let's do, I think we need a straight product rule, just a plain old product rule really quick, and then we'll do one that's a little bit more theoretical like that, okay? So, plain old product rule. So the very first one, differentiate with the product rule. Or do you want to do one of the ones like 5 through 10? 5 through 10. Okay. Let's do number 6. Number 6? Okay. So, our function f of t is 1 over t squared times t cubed minus t squared. Now, we see that this is one function multiplied by another function, right? This is something in terms of t times something else in terms of t. That's like our idea that, oh, we might need the product rule here. This one could be done with algebra, or it could be done with the product rule. But let's see how it looks with the product rule, okay? So remember the product rule is fig, so f prime of x times g of x, plus gif, which is g prime of x times f of x. And f and g are just my two functions that I'm multiplying together. So f and g are just two functions that I'm multiplying together. So I'm just going to call this one f. Okay, first of all, I'm going to rename this because it's really annoying that they do that. That's h of t because that's our big function, right? So this is f of t, this is g of t. Okay? Because this is one function times another function. And basically all I do is I just plug it into this formula. There's a whole proof on this. I'm not going to blow your brains up with it. It's not terribly difficult, but if you ever want to see it, I even posted a link to someone else doing it on the website, or I will go through it with you if you really want to know where it came from. But you don't need to, because it has to do with limits. So, so then we make a little chart. We put f of t here, and f prime of t here. Then we put g of t here, and g prime of t here, so that we can just figure them out. Okay? So f of t is t to the negative 2. Therefore, f prime of t is negative 2t to the negative 3. Agreed?
Yeah.
No?
I don't know.
You're the one that you look like.
deriving it, my dude.
Yeah.
So then we're going to do g of
The
t.
right thing where you bring down the 2 and
But
you
where you-
multiply it.
Then you subtract.
Where am I getting which one is f and which is g?
Where is everything coming from?
So when I have two functions multiplied together,
Mm-hmm.
I'm just defining one as f and one as g so that I can apply the product rule. Basically, I take the derivative of one times the other and the derivative of one times the other. I just happen to call them those f and g so that it's easier for me to figure out which one's which, to keep track. Sorry, okay. G of t is t cubed minus t squared. The derivative of that is 3t squared minus t, 2t, minus 2t. So now, once I've defined what f is, what g is, what f prime and g prime are, now I can do the product rule. So I do fig f prime times g first. So I do negative 2t to the negative 3 times t cubed minus t squared. And then I add that to this one, to gif, which is 3t squared minus 2t times t to the negative 2. And then I could simplify it if I wanted.
I did want
Do you?
it. I don't.
You don't. But it's pretty easy because you add these exponents together and you get t to the 0, so that's negative 2 minus
Negative.
plus 2t to the negative 1
Plus 3
plus 3.
But I get it wrong
minus
if I
2t
just
to
want
the negative 1.
because I'm a mess
miss the algebra if I try to do that.
No, but wait.
Wouldn't the two T's?
But wait, there's more.
Cancel, so your answer's just one.
That's kind of
Yeah.
cool.
What?
Yeah.
Do you mean the derivative of that is 1?
I feel like I could have figured that out if I didn't multiply them together.
I could have
Yeah.
figured that out if I.
So you know how it says differentiate any method you wish?
Mm-hmm.
You totally could have just multiplied that out. At the beginning, you could have said t to the negative 2 times t cubed is t, right? And then t to the negative 2 times negative, or t to the t squared is just negative 1, and then we differentiate that, and we get what we got.
One.
Should. Okay, so those are 2 different ways to do it.
Hungry.
Let's look at 16b. Don't cry. Okay, 16b. Was that the one?
Yeah.
So we found g prime, and then we need to find, oh, if f of 2 equals 3, and f prime of 2 equals negative 2, find g prime of 2. Okay.
So that would just be like negative 2 times.
Okay.
2 equals 2.
Let me wrap my head around this one really quick.
Plus 3.
So we're here. This is g prime. Yes, this is g prime.
G prime of 2 equals negative 2.
That was g prime. If f of 2 equals 3 and f prime of 2 equals negative 2.
I think. What question was that? 16b.
Oh gosh.
It's easy.
Oh, this is so much easier than I was
Just
thinking.
plug them in.
Okay, this is g prime, right?
Mhm.
This is g prime, and it just told me f prime of 2 is negative 2, and f prime, or f of 2 is 3. So literally, it just told me where everything that I need to plug into here, right?
So you just plug it in.
2 times
So at 2, g prime,
So it's 2 times
Negative
negative 2 plus 2.
yeah, g prime of 2 would be x times negative 2
Yeah. Negative 4
plus 3. So we have negative 2x plus 3, and then we plug 2 in for x, and we get negative 4 plus 3, which is negative 1.
Where did the 3 come from?
Where did the 3 come from?
F of x equals 3.
F of 2 is 3.
Yeah.
Oh, no. My bad.
Yeah. That one's really easy to overthink, as you can see.
If we could all take the test together, we'd get good grades.
Oh, for those, that's what we did. We did a quiz yesterday, but we did it's a mastery quiz, so you do it, and then I hand it back to you if you got something wrong, and then you fix it, so
I
that you
couldn't
can,
freaking multiply.
it's over the acceleration velocity stuff.
I had some questions on it.
That's
It
fine.
was easy, just don't be dumb like me.
Dying.
I'm sorry you're dying. What do you guys want to do? Do you want to do more together? You want to just work and ask questions individually?
Number 4, both me and Emily's pretty easy.
Number 4, differentiate without using quotient or product rules. Okay. So we use some algebra. Right now it's a quotient.
Oh my god.
Oh, never mind.
Never mind, we got it.
You got it?
Good.
Okay, just use algebra.
Stop saying that.
I want